In this video, we're going to talk about the side splitter theorem. So getting right into it, it says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides both of those sides proportionally. So as you can see in this description of the theorem, it says that if MN is parallel to BC, so if we know that this line is parallel to that line, then we know that AM over MB equals AN over NC. Now, we already know how to solve for missing pieces like this. The piece of advice that we've always been giving you to draw your triangles separately will always work. But what you're really going to be learning now are some shortcuts to help you save some time. So we also learned about the mid-segment theorem. Now, you want to make sure you understand the difference between these two. So the mid-segment is when we have two midpoints and we connect those two midpoints, we know that that mid-segment is parallel to the third side, but then we also know in this case that this is half of the third side. But now for side splitter, we don't need to have midpoints anymore because that was the other condition we had. We needed to have those connected midpoints, and then we had these two parallel lines. Well, now we might have a line drawn like all the way up here, and they can be parallel to the third side, but now that condition of being a midpoint is over, so we're going to figure out how to easily solve for these missing pieces. So just understanding the difference between these two diagrams is important. Mid-segment connects those midpoints here, but then for side splitter, we're just going to have a parallel line placed kind of anywhere. We might have it really low at the bottom, we might have it really high at the top, we might have multiple in one diagram, and we can use side splitter for that. Now again, remember, we can still use our traditional way. So we're going to go over both of those. So side splitter, again, is just a shortcut. So we want to always make sure we're labeling. So we have that BE is parallel to AT. Now remember, we need that condition. It said if a line is parallel to a third side, then we can use our side splitter. So it says CB is 3, CA, which is here, is 10, CE is 6, and it wants the length of ET, so we will go ahead and put that as X in our diagram. Now the first thing that I'm noticing to do is it gives us the value of this entire side AC, and then we have that this little piece here is 3, so I'm just going to go ahead and fill this in as 7, because to use side splitter, you're going to want a value for all 4 of these pieces, like for AB, BC, CE, and ET. So again, where those sides are being split, if you have values for each of those 4 portions, side splitter, you can create a proportion in like 2 seconds. So for side splitter, we know BC over AB is going to be equal to CE over ET. Now you're going to make it's going to be more clear with numbers. So just substituting those in, we can do 3 over 7, and again, that's this piece over this piece, equals 6 over X, and then we can cross multiply. We'll get 3X equals 42, I believe. X equals, I want to say 18. I don't even know what the number is, but whatever you get when you do 42 divided by 3, that would be your answer. Now you can also do this using our traditional way. It might just take you a little bit longer, but you want to start off the same way. 6, we want X. Now, this is going to be a little different because when you draw your two triangles separately, we'll have CBE, and we want to bring those values over. But then in our larger triangle, we're going to have CAT. We have 10 here. Now, in types of diagrams like this, you're going to have to make an expression. So this is going to be 6 plus X. And your diagrams might get slightly more complex. But your proportion here, you can do 3 over 10. 3 over 10 equals 6 over 6 plus X. And then when you cross multiply, you want to just make sure you're distributing. So you'd get 18 plus 3X equals 60. And then if you solved, you should get the same answer there. Now, what I like to do is I like to look for triggers or things that can tell me that I can use side splitter. And again, those triggers for me is if like we're talking about these two sides that are being broken up here. So for example, BE is intersecting this side and this side. So if we're talking about all 4 of those portions, then I can use just side splitter. Okay, this side over this side equals this side over this side. But if it's a slightly more complex diagram, or even if we're talking about, like let's say for example, we were looking for like BE and AT, those two sides are not being split at all. So if the side is not being split, you cannot use side splitter. It's kind of in the name. All right, so make sure you understand you can use both methods here. You can always revert back to the traditional way. It might just take you a little bit more time, but you want to also make sure that you're comfortable. Is if you can use this shortcut, you should, because you want to have all the time that you can get on your exam in June.